footsteps behind you at 2:13 in the morning, 8 of them clicking against pavement, and your entire nervous system is about to overreact to a woman carrying oranges. You slow down. They slow down. You stop. They stop. Your shoulders climb before you've even decided to be scared, and one ear turns toward the sound even though human ears have roughly the turning radius of 2 decorative door handles. Your grip tightens on your phone, and the same brain that spent this afternoon forgetting a password you created yesterday is now running surveillance for the entire street. Then the walker crosses to the other side, passes you, and turns out to be a tired nurse carrying a bag of oranges. Nothing happened, and yet your body reacted as if those oranges had a knife. That response is easy to mock in daylight. At night, with another set of feet matching yours step for step, overriding it feels almost impossible, and the reason comes down to 3 things the nervous system hates in combination: approach, agency, and uncertainty. Something is closing the distance between you. It was probably produced by another body, and the face, hands, size, destination, and intentions of that body are hidden from you. The footsteps aren't proof of danger. They're a demand for information. On paper, a footstep is nothing, just a brief impact, a scrape, a pause, repeat. But your auditory system doesn't receive a row of meaningless thumps. It starts pulling the sound apart immediately. Which side is it on? How far away? Is it getting louder, and is the interval between steps shrinking? Does the heel land hard? Is the rhythm steady, hesitant, hurried, or suddenly matching yours? One body or several, shoes or paws, pavement or gravel, someone approaching, passing, or changing direction. Your conscious mind gets the final memo, footsteps behind you, but a lot of sorting happened before that memo ever reached the desk. Hearing earns its keep here because it covers the part of space vision gives up on. Your eyes hand you a detailed slice of the world in front of you, while your ears keep a rough watch in every direction, including the inconvenient half of reality attached to your back. To place a sound left or right, the brain compares tiny differences in when it reaches each ear and how loud it is at each ear. Front and back are the hard part, since a sound directly ahead and one directly behind can produce nearly identical timing and intensity differences. The folds of your outer ear filter frequencies in direction-specific ways to help resolve that, and small head movements pitch in too. That reflexive glance over your shoulder isn't cowardice, it's a data request. Footsteps make this problem easier and worse in the same breath. Easier because they repeat and every impact hands the brain another sample. Worse because every one of those samples might show the source getting closer. Researchers actually have a name for an approaching sound, a loom, which makes it sound like a haunted textile machine, and the tendency to prioritize it is called auditory looming bias. Sounds perceived as approaching get more attention than equivalent sounds perceived as fading away. In lab experiments, people respond faster to looming sounds. They judge the approaching change as bigger than the receding one, and they anticipate contact sooner than the physical signal actually warrants. That's technically an error. It's also a useful one, because if the sound belongs to a falling branch, a vehicle, a charging animal, or an angry person with zero interest in personal space, 5 unnecessary feet of caution cost you almost nothing, while 5 missing feet can be the whole event. Gavin Bidelman and Mark Myers ran a small EEG study where listeners classified tones as approaching or receding, and the approaching tones got faster responses every time. Brain activity tied to the 2 judgments started diverging fast, with prefrontal differences showing up within roughly 200 milliseconds of the sound, even starting. 200 milliseconds is less time, and most people need to realize a group chat has turned into an argument, and your system is already prioritizing direction before you've composed the sentence, "I appear to be uncomfortable." Here's where the tidy evolutionary story gets messier. Many looming experiments create the sense of approach simply by raising a sound's volume, and louder sounds are just easier to notice. So maybe no specialized alarm system is needed at all. Maybe a speaker knob explains the whole thing. That objection has real teeth. A 2024 EEG study found that a model of the nonlinear processing happening in the auditory periphery could account for a large chunk of the measured difference between looming and receding sounds, meaning some of what looks like the cortex treating approach as special might actually start with the mechanics of a rising intensity signal. Then in 2026, a team led by auditory researcher Andrew Kolarik tested blindfolded listeners judging the distance of virtual sounds moving along 11-meter paths, and when loudness was the main cue to distance, a simple model of changing volume predicted several of the observed approach rate asymmetries on its own. None of that explains looming away entirely, though. A separate experiment held overall intensity constant while changing only direction-specific spectral cues, and listeners still produced more consistent behavioral and neural responses to sounds they perceived as approaching. So it's all just volume is too simple an answer. The honest version is that approaching sounds gain priority through several different cue-dependent processes, some of which trace back to loudness and peripheral encoding, and others that persist even when overall level never changes. None of this proves your prefrontal cortex has a tiny security guard stamping T-hard onto every approaching noise, either because approach isn't the same thing as danger. Your friend running up to surprise you is approaching. So is a waiter carrying dessert, and so is a golden retriever conducting an unscheduled emotional reunion. Direction gets priority, but meaning still has to be worked out separately. And footsteps carry a lot more meaning than a lab tone ever could because they're action sounds, noises made by a body doing something. Listeners can use tempo, intensity, and regularity to form rough impressions about a walker's emotional state and characteristics tied to them or their footwear, though the accuracy here isn't magic. These impressions are probabilistic. Some of them lean on experience or expectation or plain stereotype. And your brain isn't measuring a stranger's exact height through the pavement like some sonar-equipped tailor. It doesn't wait for a face before it starts sketching, though. Footstep sound can even reshape the picture you hold of your own body. And in one experiment, participants who heard modified versions of their own steps through headphones actually felt lighter when the feedback was shifted to higher frequencies, which changed features of their gait. Sound wasn't just reporting what the body was doing, it was helping the brain estimate what kind of body was moving in the first place. So a hard, low, rapid footfall behind you doesn't stay an acoustic event for long, it starts becoming a candidate person. Heavy maybe, close maybe, hurried, tense. Your brain is sketching a stranger out of impacts on concrete, using a pencil it found in the dark, and context decides how much of that sketch should actually worry you. One set of footsteps at noon in a busy station barely registers because there are faces, exits, witnesses, open shops, and dozens of competing feet, and the sound belongs to an identifiable social scene. At midnight in an empty parking structure, those reassuring variables vanish one by one. The footsteps become isolated. Vision can't identify the walker. Allies are few, and ambiguity climbs at exactly the moment the source appears to be closing distance. This is the reversal worth sitting with. Ignorance doesn't make the alarm system relax. Ignorance is precisely what makes checking feel urgent. The less you can verify about an approaching agent, the more attention the sound earns, not because the system knows there's danger, but because it has no evidence there's safety. Your body also keeps a working map of the space immediately around it, what researchers call peripersonal space, the region where objects are close enough to be reached, to reach you, or to demand action right now. It's not a fixed bubble stamped around your skin. It shifts with the body, the task, available tools, and the meaning of whatever's approaching. Scientists study this by combining sound and touch. A participant gets a small tactile stimulus while a sound appears to move closer, and as that sound enters near body space, responses to the touch actually speed up. Hearing and touch start sharing a desk once an object gets close enough to make contact. Rear space seems to get especially strong multisensory treatment, since it can't be checked visually without turning your whole body. A 2024 experiment found that approaching sounds sped up touch responses more strongly behind participants than in front of them, even though their explicit judgments about auditory distance and speed showed no such front-rear difference. The brain, in other words, can start preparing for something near your back before your eyes have filed any report at all. That space serves offense and defense equally. A mug within reach is available to grab. A wasp within reach is available to become your entire personality for the next 30 seconds. Same space, completely different plan. The meaning assigned to a possible walker can shift where your discomfort even begins. In one experiment, blindfolded participants listened to either an aggressive or a neutral recorded conversation, then heard footsteps approaching and stopped the sound the moment it felt uncomfortable. After the aggressive conversation, people stopped the footsteps farther away, even though the steps themselves hadn't changed at all. Only the implied person behind them had. This particular study measured interpersonal stopping distance rather than every neural definition of peripersonal space. But it illustrates the bigger mechanism clearly. Context changes how much distance feels like enough when an unidentified person seems to be closing in. Anxiety can shift that margin too, though not in one single direction across every task. A small study measuring a defensive reflex near the face found that people with higher trait anxiety tended to show a larger defensive boundary. That doesn't make an anxious person broken, and it doesn't mean the feared interpretation is correct. It just means the threshold for close enough to prepare gets set differently. The system is buying itself response time and paying for it with more false alarms. That trait holds a deep logic. One animal that turns toward 10 harmless rustles just looks annoying. Another that ignores the one approach that actually matters looks efficient, briefly, right up until it doesn't. When the costs of two mistakes aren't equal, perception and decision-making tend to lean toward whichever mistake is cheaper, a pattern sometimes called error management. This doesn't prove modern footstep anxiety is one neatly isolated adaptation either. The response likely recruits older, broader systems built for sound localization, approach detection, biological motion, social intention, and near-body defense, all bolted together. Evolution works like a cave mechanic. Keep whatever functions, bolt the parts together, and don't worry that the dashboard now screams when a leaf touches the cart. Other primates show a related pattern. In one study, rhesus monkeys oriented longer toward rising intensity complex tones than toward match tones that faded away, though the same preference didn't show up identically for every kind of sound. That finding suggests some sensitivity to auditory approach doesn't require language, horror films, or a childhood lecture about stranger danger, though it doesn't prove the monkeys believed a predator was closing in, or that human sidewalk fear traces back to one recurring Stone Age scene. The exact evolutionary history never left meeting minutes. What can be said narrower and stronger is this. Hearing supplies information beyond the visual field. Approaching sources sometimes demand action, and footfalls carried information about moving bodies long before anyone paved a road. Around a fire, faces inside the light could be read, but beyond it, feet pressed into soil and the darkness refused to hand over a name. So turning toward the sound gained information every time. Sometimes it revealed a friend, sometimes an animal, sometimes one friend being weird, which may be the most ancient category of all. The same machinery now runs in cities built from surfaces that exaggerate every one of its cues. Concrete reflects sound. Parking structures turn one walker into a percussion section. Dress shoes announce a stranger from half a block away, and streetlights carve out islands of visibility separated by blind gaps. Modern social knowledge pours meaning onto the signal on top of all that. Previous harassment, local conditions, body size, gender, time of day, the presence of other people, and whether an exit is even available all shape how costly an unknown approach feels. The same footsteps aren't equally risky to everyone, and different people have good reasons for setting different thresholds. One person hears quick steps and keeps walking. Another checks a shop window reflection, pulls a headphone out, changes direction, crosses toward a crowd, or calls someone. That attention isn't a referendum on courage. It's a risk calculation made by a particular body in a particular environment. There's a deeply social complication layered on top of all this. Walking rhythms can align. People walking together or moving through a crowd sometimes drift into synchronized steps, and that doesn't prove a stranger behind you is unconsciously matching your pace, since two people with similar walking speeds will naturally produce similar rhythms anyway. Your brain doesn't get a certificate explaining which explanation is the correct one though. You speed up, and the other walker speeds up because you're both approaching the same crossing light. Now the pattern looks worse. You cross the street. They cross because their car happens to be there. They notice your discomfort and slow down to open some distance, and you hear the change and wonder why they suddenly shifted pace. Two innocent route choices turn into a tiny thriller where every coincidence seems to confirm the wrong model, and the person behind you may be running their own risk calculation in parallel, crossing over specifically to seem less threatening, which you then read as suspicious anyway. Two mammals try to diffuse tension and accidentally choreograph the world's least romantic dance. The alarm doesn't need certainty to grab your attention. Its entire job is to interrupt whatever you were doing and force an unresolved approach to the front of your mind. Once the walker is identified, the model gets dismissed, but before identification, dismissal is the gamble. Phones make the timing even worse. Your eyes are aimed at a glowing rectangle. Noise-canceling headphones strip out the continuous ambience that would otherwise let you track a source gradually, and navigation pulls your attention toward a route line instead of your surroundings. Then a heel strike breaks to 3 meters behind you, already well inside the distance where your brain would have preferred to start getting updates. The old system expected incomplete information trickling in gradually. The modern setup sometimes withholds nearly all of it and then delivers one loud sample at close range instead. So now the approach detector has to work amid echoes, engines, recorded audio, runners, shared GPS routes, crowded pavement, true crime memories, and strangers walking toward the exact same apartment entrance as you. The city is extremely good at generating realistic false positives. A runner approaches quickly because that's the entire point of running. A delivery driver follows you through several turns because you were both sent to the same building. Someone steps off a train behind you and walks the same 6 blocks because neighborhoods, it turns out, contain more than one person. The alarm tags the pattern first and waits for identity to show up later, and that order feels unfair once nothing bad happens, since you may feel silly for turning around. But feeling silly is evidence collected after the uncertainty already ended, and the system had to allocate its attention before that evidence ever arrived. No version of this response is infallible. Anxiety can make the safety margin exhausting to live with. Trauma can teach a brain that harmless cues predict danger anyway. Hypervigilance can trap attention on threat long after a reasonable check would have settled the question. The fact that a response has protective logic behind it doesn't make every setting of the alarm healthy, accurate, or fixed in place. And brains learn safety too. A familiar route, better lighting, company, repeated benign experience, hearing the walker's voice, catching a reflection, or simply turning around and identifying the source. Any of these can bring the uncertainty down. The goal was never to shame the alarm or obey it like an oracle. It's to understand what information it's actually asking for. Usually the request is simple. Locate the source, judge its direction, identify the agent, preserve enough space to act. Answer those questions, and the shoulders drop, the phone grip loosens, and the tired nurse with her oranges goes back to being a person carrying groceries instead of an unresolved body moving into reach. You can't ignore footsteps behind you for the same reason you can ignore footsteps moving away. One pattern is closing a question. The other is bringing the question closer to your body. At 2:13 in the morning, those 8 clicks aren't proof of danger. They're evidence that something human-shaped might be approaching through the one part of space you can't see. Your brain would rather interrupt your walk, invent one embarrassing thriller, and get corrected than find out too late that this was the rare scene where the footsteps never passed. When you hear footsteps behind you, do you speed up, turn around, cross the street, or pretend you noticed absolutely nothing? Pick one in the comments and defend your extremely scientific method. If you want to keep understanding why your brain and body do things that make no sense in the modern world, subscribe. We've got a lot more of this coming.